Once again everyone, and I want to use this opportunity again to welcome you to Mathematics Solution Center. Today I'm going to be taking you through the laws of logarithm, and it goes like this. If I have log pq to base 10, this is going to be equal to log p base 10 plus log q base 10. So this is law number 1. The question is this law actually correct? How come? How can we prove that this law is correct? To prove how a mathematician came about this law, you have to have some basic knowledge on laws of indices. So take for instance, let's say let p equals 10 raised to the power of x, and let q equals to 10 raised to the power of y. So this is what we have. Relationship between logarithm and indices. We can change a logarithmic equation to an initial equation. So that means in this case, x is equal to log p base 10. So this is how we change an initial equation. So let's do the same thing at the other way, at the other side. So that means in this case, y is equal to log q base 10. Now let's find the product of p and q. Therefore, pq is equal to 10 raised to the power x. Don't forget that p is 10 raised to the power x, as written above. Then times q, which is 10 raised to the power y. Therefore, we have pq to be equal to 10 raised to the power x plus y. So we are applying the laws of indices here. That means x plus y is equal to log pq base 10. But take note, we've already said that x is equal to log p base 10 and y is equal to log q base 10. So, and we have x plus y. So we are going to substitute for x log p base 10, and we also substitute for y log p base 10. So instead of x, I will write log p base 10, then plus y is equal to log q base 10, and is equal to log pq. So the law, this is how this law of logarithm is gotten. So the question is, how do we apply it? Take for instance, I have a log 20 base 10, log 20 base 10 plus log 5 base 10. So this will be equal to log, applying the law now, since log p plus log q is equal to log pq, then it's going to be log 20 times 5. So to base 10. And take note that before you apply this law, your logarithm must be in the same base. I'm not saying it must be base 10, it can be any other base, but it must have a common base throughout. Therefore, we are going to have is equal to log 20 times 5 is 100 base 10. And this log 100 base 10 means what will be the power of 10 that will give me 100 as an answer. So log 100 base 10 is 2. So the power of 10 that will give me 100 as an answer, the power of the base. The logarithm of a number is the power of its base. So the answer is 2. So we are going to law number 2 law, which is quotient law. We can call it the quotient law. So that means if I have log p divided by q in base 10, or any base, is going to be equal to log p minus log q. So it still follows then the same principle we used the other time. So if we say let p to be equal to 10 raised to power x, and then q is equal to 10 raised to power y. Therefore, x is equal to log p base 10, and y is equal to log q. Log of q base 10. So if you look at the expression, we have p over q. So let's evaluate p divided by q. P divided by q. So this is going to be equal to what? What is p? P is 10 raised to power x divided by 10 raised to power y. That is the value of q. So evaluating this, we are going to have P over Q to be equal to 10 raised to power x minus y. So we're still applying the law of indices there. So we can see this as a single term, okay? And this is x minus y is the power of 10. So we can apply that conversion of a initial expression into logarithmic equation. That means we have log P over Q base 10 is equal to x minus y. But take note, we've already taken our x to be log P base 10 and our y is log Q base 10. So let's substitute in this. Therefore, we are going to have log P over Q in base 10 is equal to x is log P base 10 and then minus y, and my y is a log Q base 10. So this law is proven. So how do we apply it? Take for instance, I have log, let's say we have a log 16 minus log 4 base 3. Then this is going to be equal to log 16 divided by 4 base 3. So 16 divided by 4 is actually 4 base 3. So that is our answer. So number 3 law, so if I have log P raised to power of n base n, any base 10, n log P base 10, this is what we are going to have. So that is the law. The power of P goes to the front and multiply log P base 10. Let's verify this by trying to apply it. Let's verify it. Okay. Take for instance, I have log 4 base 2. The meaning of log 4 base 2 simply means what is the power of 2 that will give me 4. So the power of 2 is what? Is actually 2. That is what will give me 4. So we can say this is equal to x. Then we solve. We convert the logarithmic equation to initial equation. That means it turns to 2 raised to power x is equal to 4. So that means 2 raised to power x is equal to 2 raised to power of 2. So since the bases are equal, the powers are equal. So x is equal to 2. But going back to this our law, let's try to apply the law on this question. Therefore, I have log 4 base 2. So I will not equate it to anything, but I will just evaluate it further, which is equal to log. I will write 4 as a power of a number like 2, because I have 2 as my base, then 2 raised to power 2, then base 2. So this is equal to 2 goes to the front as stated by the law, then log 2 base 2. Now log 2 base 2 is actually 1, because what will be the power of 2, the base, that will give me 2? So it should be 1. Therefore, the answer is 2 times 1, which is equal to 2. So log 2 base 2 is 1, and this law is verified since it gives us the same answer as the previous method we used. So let's go to number 4 law. Number 4 law, we can call this the power of the base. The power of the base. Take for instance, if I have log, let's say P and then B raised to power of n now. So the base is raised to power n. Then the law says that n will go to the front, but you take the inverse, which is 1 over n, then log P base B. B remains, but the power of B goes to the front. So this is what we have. So take for instance, let's try to apply this. If I have log, so we are going to try to solve this in 2 ways. So let's equate it to x using the first method. So we have 9 raised to power of x is equal to 27. So this is the same thing as 3 raised to power of 2x. The powers we multiply then is equal to 3 raised to power of 3. So since the bases are equal, the powers are equal. Therefore, 2x is equal to 3. And then it shows that x is equal to 3 over 2. Now we want to apply this law that we just learned now to solve this same problem. I'm going to solve it just exactly beside this question. So I'm going to start with this. So this is now my log 27 base 9 is the same thing as log. I'm applying the first law and the second. I'm applying that log 3 and log 4 together. So I'm having 3 raised to the power of 3. 3 raised to the power of 3 is 27. I've written 27 in another way around. And then 9 is 3 raised to the power of 2. So I will take 3 to the front. I can also take the power of the base to the front, which is 2 to the front. So 3 is coming as 3, and then times 2 is also coming as 1 over 2 as the reciprocal. 1 over 2. Then I have log 3 base 3 left. So the log of a number to the base of that number is 1. So it means what power will 3 be raised to get 3 is 1. Therefore, I'm left with what? 3 over 2. So you can see it's the same answer as the previous method I have used. If I have a log p base b, this is the same thing as log p base 10 divided by log b base 10. So we call this law, we call it change of base law. It is very, very important. You can use it to change the base of your logarithm. So you can use it to change the base of your logarithm. So let's just go to law 6. So this one we have even been using it. We have been using it, let's say log a base a. So log a base a is equal to what? 1. The log of a number to the base of that number is 1. So let's say log 7 log 1 to any base. The answer is what? The log of 1 to any base at all is 0, because log 1 base b is simply a question that b raised to power of a number, the answer we get is 1. What is that number? So a number that when you raise any number to it, and it will always give you 1, is 0. So anything raised to power 0 is 1. So log 1 base b is always 0. So we are going to take some other questions. I'm going to be bringing in some questions that I'm going to solve using the laws we have learned so far. So let's take a look at this question. Log x base 3 plus log x minus 8 base 3 is equal to 2. So we want to solve this question and get the answer to it. So I'm going to use the law of logarithm to combine log x base 3 and log x minus 8 base 3 together. So using our product law, I have a log x times x minus 8, then base 3 is equal to 2. Then I can now convert the logarithmic equation to an initial equation. So that means x into bracket x minus 8 is going to be equal to 3 raised to the power of 2. Therefore, with this, I have open the bracket, x squared minus 8x is equal to 9. So we have x squared minus 8x minus 9 is equal to 0. X squared minus 9x plus x minus 9 is equal to 0. So we factorize this, we group and then factorize. So we have x into bracket x minus 9 and then plus 1 into bracket x minus 9 is equal to 0. So we have x plus 1 and then x minus 9 is equal to 0. So that means x plus 1 is equal to 0, or x minus 9 is equal to 0. Why this? Product of two things equal to 0, so it is either one of them is equal to 0. So if x plus 1 is equal to 0, it means that x is equal to minus 1. If x minus 9 is equal to 0, that means x is equal to 9. So we go for the positive answer. So our answer is 9. Another question here, solve the logarithmic equation. Log 6 minus x base 2 is equal to 3 minus log x base 2. Okay, what we have to do here, let's collect the like terms. So we have log 6 minus x base 2 is equal to 3 minus log x also base 2. So this is the same thing as log 6 minus x, then plus, don't forget your base 2, log x base 2, and is equal to 3. So we use the product rule to combine these two logs together. So we are going to have log x into bracket 6 minus x base 2 is equal to 3. Then we convert the logarithmic equation to initial expression. So it means that 2 raised to the power of 3 is equal to x into bracket 6 minus x. So we have 2 raised to the power is 8 is equal to 6x minus x squared. So take everything to the same side and bringing everything to the left hand side. So I have x squared minus 6x plus 8 is equal to 0. So we look for two numbers that can be multiplied together to get 8, add together to get minus 6. So the two numbers are minus 2 and minus 4. So we have x squared minus 2x minus 4x plus 8 is equal to 0. And then we group into two parts. Then we factorize this. We are going to have x into bracket x minus 2, x minus 2 is equal to 0. So we have x minus 2 and x minus 4 is equal to 0. So it means that then x minus 2 is equal to 0 or x minus 4 is equal to 0. So it means x is equal to 2 or x is equal to 4. These are the two possible answers for x. X is equal to 2 and x is equal to 4. So I think that is option A. Option A is the correct answer. So this will be the last question we are going to solve for today. And the question goes like this. Log 27 base 3 is equal to 2x plus 1. So this is very simple. Just convert it to initial equation. So that means 27 is equal to 3 raised to the power 2x plus 1. So since the right hand side is in the form of 3 raised to the power something, I will see if I can express the left hand side to be in the form of 3 raised to the power something. Yes, I can do that. So 27 is the same thing as 3 raised to the power 3, and that is equal to 3 raised to the power 2x plus 1. So since the bases are equal, the powers are equal. So it means 3 is equal to 2x plus 1. So take 1 to the other side. 2x is equal to 3 minus 1. So 2x is equal to 2. Divide both sides by 2 over 2 is equal to 2 over 2. 2 cancel 2. So we have x is equal to 1. So that is the answer to question B. So we have come to the end of today's tutorial, and I want to appreciate you for your time. Please don't forget to subscribe to this YouTube channel. I will really appreciate that. Thank you. See you in our next video. Thanks. You can put your comment in case you have any question in the comment section. Thanks and remain blessed.